Welcome to the May 5th update of the IHME COVID-19 forecasting model. My name is Alan Featherstone. This is work with an undergraduate student at K-State, Julia Maddock, and my son, Jonathan Featherstone, who is doing a lot of spreadsheet analysis on the data. Again, as we're all aware, the virus is having a major effect on the economy. With the unemployment rate closing in on 20%. Again, this is the highest unemployment rate we've seen since the Great Depression. Since the middle of March, more than 30 million U.S. workers have filed for unemployment due to the shutdown of a significant share of the economy, and this has had major disruptions in the food sector, along with the service sector generally across the country and across the world. The Institute for Health Metrics and Evaluation at the University of Michigan is playing a large role in the formulation of policy simply because these models are used very heavily by policymakers, and it's pretty difficult now to essentially turn on the news without hearing about the latest projection out of the University of Washington. I think it's really important to understand and document the ex-post performance of the prediction model and the revisions that are made in that predictive model. This is an update of the April 28th discussion. One of the things I think that's very important is there was a major revision that occurred with the model release on May 4th, which uses data through May 1. This analysis here will provide information for 30 states in terms of since last time we've added 16 more states. And so the goal here is to give a pretty broad overview with regards to different regions within the country. We've had this slide before in terms of, again, the original model was essentially a statistical model that used a parameterized spline, kind of the sigmoid function, which has a shape of the logistics. It was solved using curvefit in Python. Essentially, it used a bounded nonlinear optimization problem, a fairly complex model. It's constrained. And so it also uses derivatives, and essentially the model is constrained such that the parameters have the desired sign. It uses national government and WHO websites. Specifically, the Johns Hopkins coronavirus data is used. Again, as of May 5th, the article is still in the peer review process. In terms of where we get our actual data from, is we've actually begun using the COVID tracking information. And one of the things that is there is there's actually a divergence between actual reported deaths between Worldometers and the COVID tracking, and so certainly there. And then there was an article that came out from the CDC that indicates that the deaths that they've reported are quite a bit less. In terms of there was a major update in the model in the middle of April, and another major update in the model as of May 4th. Essentially, some of the major changes that occurred from the previous modeling approach to the one released on May 4th. A lot of smoothing occurred in the data to estimate the parameters. Originally, they were using raw data, then they moved to a 3-day average, and now they're using a 10-day process in order to estimate the model. One of the things they've added a number of variables. For example, they've added the number of COVID cases. They've added the COVID hospitalizations. The goal there is to take that information and use that to predict deaths a period of time later. They've also adjusted for the scale up in testing. We're doing a lot more testing nationwide than we had previously. And so essentially one of the assumptions that is embedded from in the model is as tests double, the cases increase by 22%. And so certainly the scale up in testing is used. Essentially, they've moved from a situation where the original model had essentially 7 independent variables. The mid-April model had 13, and now there's 29 variables. They're using mobility data. This is tracking data of cell phone technology that allows to determine how much people are moving. There's temperature data. The thought there is that as temperatures increase, the virus is more susceptible to ineffectiveness, and so as temperatures rise, the virus outside is able to survive at a much slower rate. Again, they have testing rates, they have population density information, but the big thing is, in a general rule, and I think this is very important as you think about the model going forward and the results and just how confident you are with regards using those to make decisions, is the fact that as you add more variables, you get a better in-sample fit, but that does not always mean that you're going to get an out-of-sample fit or a better prediction. And so that's one of the things I think that's certainly interesting to look at, is that how does the out-of-sample fit change as we put more and more inputs. We know that adding more variables is going to get you a better in-sample fit, but does that really translate into predictive power outside? And the economic research is certainly mixed, and there isn't a one result there, but there is some evidence, or quite a bit of evidence, that the more variables you add and the better prediction you get in sample, many times that doesn't lead to a better out-of-sample fit. To show a difference in terms of the data with regards to looking at this, the red line, and we have this for Kansas, is the COVID data. Essentially, these are the actual deaths there. One of the things that's interesting is Kansas actually retracted a death, and so one day they actually had a -1 in terms of deaths. And again, one of the things in terms of following this model is the frustration with regards to the data and the consistency of it. And certainly as an economist, that makes modeling very difficult. The green is essentially the data that actually inputted into the model on April 28th, the last model before they moved to the new smoothing process. And then May 1 essentially is the smoothing process. And so you can really see that they've taken the variability out. And again, as an economist, sometimes you worry in terms of if you pre-process the data, what does that do from a predictive power, and does that really improve your model or not in terms of providing perhaps a false security with regards to the predictive power, especially as you think about that out of sample. You can also see, for example, New York in the United States. Again, you see the April 28th data that was inputted in the model, and then the May 1st with the smoothing process. Certainly there, if you look at the U.S., certainly that smoothing process leads to another inflection point with regards to the curve. And again, you can see the red line, which are the actual reported deaths. We have those for California, Florida, Texas, Illinois. One of the things about Illinois there, you don't see the red line. Essentially, it traces the green line almost identically. You can see a little bit of a difference there. But again, in terms of this, just illustrates in some respects the quality of the data coming in terms of, you would hope, for example, the green and the red would trace each other all the way through, but unfortunately that is not the case. In terms of, you also see this for Georgia, Michigan, South Carolina, Tennessee. The big thing there is to really look at how those input data have been smoothed kind of in the May 1 model. And so certainly that is there and pretty important. And then you have Colorado, Nebraska, Missouri, and Oklahoma there. In terms of what this slide does is actually look at how these projections have moved over time. The original model is in purple, and then essentially in Kansas it moved up, and then it moved down to the orange line. Then it moved up a little bit to the blue line, which essentially was a smoothing of the orange or yellow line. The projected distribution moved up again to the 12th. Then in terms of looking at that, it moved down to the red and then moved up to the green, and essentially the last model, basically the distribution flattened out quite a bit. One of the things you'll end up seeing is certainly the tail is much longer than any of the previous models, and so that expected death all the way through June ends up being more than one. This results kind of in the cumulative forecast, and we have a number of these done for the different things. You can end up seeing that some of the original models in Kansas was up in the 680 death range. You can see that it actually decreased in the red, which was the April 17th forecast, all the way down to about 180. Now you can end up seeing that the most recent model, it ends up being a flatter sigmoid function, and essentially that moves up to essentially a little bit over 200, I think about 260. In some respects, it ends up being about where the model was on April 5th. And so U.S. as a whole, one of the things you end up seeing is essentially we were in this range between 80 and 60,000 deaths. The most latest estimates move up to 130,000, and again it tends to be a flatter sigmoid function. It doesn't reach the peak near as quick. In terms of New York, essentially if you look at the original model, it was kind of down in this 13,000 range. Now essentially the projection is that that's jumped up into the 32,000-33,000 range. In terms of California, again there is moved in terms of it kind of moved up originally, then it moved down and kind of stayed kind of in that range between 1,000 to 2,000, but more recently with the more recent estimates, the cumulative death forecast is actually now going up to above what it originally was. In terms of New York, again, you can take a look at that, but Florida, same type of thing in terms of the original model. Was kind of this purple line kind of up around here at about 6,800. You can see that the model has been anywhere between 1,000 and 7,000 deaths. The most recent estimate kind of moves it up into this area where we're looking at roughly about 4,000 deaths. Illinois, you can see that the most recent revisions, again, if we look at the original, it's sitting right there, and so essentially the revisions have moved the death from about a little over 2,000 to above of 6,000, and so certainly there has been a big movement there. In terms of Texas, again, it's increased, then it decreased. As of 4/17, we were down kind of at this 1,000 range. And now, if you look at the estimates, it's by the August 4th, it's expected to move into this range of about 3,600. In terms of one of the things that we're going to look at here is essentially how this model has done from the original. And so we have kind of regional models, and we'll go through these pretty quickly. And all this information, if you want to take a look at the slides, they're on agmanager.info. And so again, if you just type in agmanager.info, you can get a copy of the slides. and take a look at them. So we're going to go over those pretty quickly. But in terms of, if you look at the original model here, it doesn't really look that bad for the U.S. as a whole. You do have some cases where it's bigger, some cases where it's less. Again, in some respects, the models perform fairly well, especially given the change in data definition between partway through where how they were counting COVID deaths have changed. If you look for Kansas, essentially the distribution has been flattened for a long period of time, and if you really look at it, essentially it's bouncing between roughly 1 to 6 deaths. You see, in some respects, a slow trend line negative, at least from that portion. The big thing to realize is it's outside of this 95% confidence interval that it started with. The other thing I think that's pretty important to think about is just where we've seen the deaths by age group. And essentially what I've done is I've went to the Kansas Department of Health and Environment to essentially look at the information here in terms of where the deaths have been, and this information was pulled as of May 5. And so looking at this, you essentially can see that most of the deaths, in terms of if you add those two numbers together, you're looking at roughly 70% of the deaths are in this range of 85 plus years. What I ended up going back and looked at was just what were the mortality rates in terms of 2018, just to allow you to make a comparison. So far in Kansas, we really haven't had any mortalities, less than 42. And so if you look at the age groups, roughly in Kansas, 4.2% of the mortalities in Kansas in 2018 were less than 35. And so you can kind of compare what the normal mortality rate would be in terms of what we're seeing across the distributions. And really, if you look at it, the big difference is in this 85 plus type range. In terms of looking at some of the states around Kansas, you'll end up seeing that other than a period of time here, generally Missouri over the last week or so has been below the original forecast. If you look at Nebraska, they've been below the forecast and beginning to get outside of that 95% confidence interval. Oklahoma has been outside the 95% confidence interval, again, well below what the original projections are. Now, if we go to the Northeast, we look at New York. Essentially, it followed pretty well up until about that point, at which point the mortality, number of mortalities or number of deaths actually is above the mean, as it actually moved outside that original 95% confidence interval. And again, this is some of the data that you're dealing with in terms of essentially from there to there, certainly a big peak. But again, if you look at where Massachusetts is, well above the original 95% confidence interval. Connecticut, well above the original 95% confidence interval. New Jersey, well above the original confidence interval. Pennsylvania, certainly above the original confidence interval. In terms of Rhode Island is kind of within there, although more recently they've been above. Delaware, they've been below essentially the 95% confidence interval for much of the period. New Hampshire, again, over the last 2-3 weeks have been below. Vermont, essentially, in some respects, has been kind of following that down. Maine has been quite a bit below the projections over the period of time. And so within the Northeast, as you move more north, some of those states have done much better than the original projections. And kind of in that New York, New Jersey, Pennsylvania, Boston, Massachusetts area, Connecticut, they've certainly experienced much worse conditions than were expected. Moving into the southeast, you see Florida kind of hovering along that lower boundary. Georgia has been generally under that lower boundary. South Carolina generally has been below the lower 95% confidence interval. Tennessee has generally been below. Kentucky, in some respects, was bouncing around, and in some cases was above, and now essentially you look at it and they tend to be below that confidence interval. Alabama tends to be below the confidence interval. Louisiana tends to bounce around in some respects, and part of this was some of the issues with New Orleans. Certainly they've been above the confidence interval for a period of time more recently. And then Arkansas, or Mississippi, has been kind of near the lower bound, and Arkansas has been fairly low. We then move into more of the Midwest. You can see where Illinois is, and at some point up until the middle of April, they were tracing pretty well. After that, they've actually been above the expectation from the original forecast. Michigan has been above for the last few months or last few weeks, and in some respects they've broken out of that 95% confidence interval. Minnesota has had a much better experience where they've been below. Texas, you can kind of see that they've been hovering on that lower bound. Colorado generally has been on that lower bound. Again, my guess between the peak and the spike is just how deaths were reported. And so I think there's probably an exaggeration on both of those, as there probably was in that situation. Arizona, generally below. New Mexico, generally below. We move into California, again, generally below the original expectations. Washington, certainly generally below, except again there was a peak there with regards to the situation. Alaska, essentially generally below. Hawaii, generally below. And then we can do the same type with the cumulative. If you look at the cumulative, the U.S. is pretty close to the original line. Kansas is much below, and again Missouri is pretty close to the projections. Nebraska is actually breaking out where they're beginning to be below the lower bound. Oklahoma has been below the lower bound. New York essentially is on the other side where they've been above the lower bound. In terms of Massachusetts has been above. Connecticut has been above. New Jersey, quite a bit above. In terms of Pennsylvania, on the high side, certainly within the 95% confidence interval. Rhode Island has been above, but then you go to Delaware that's below, New Hampshire that's below, Vermont that's below, Maine quite a bit below. We now move to the southeast. Again, Florida is hovering on that lower bound from the original forecast. Georgia is below. South Carolina is below. Tennessee is below. Kentucky is a little bit high, but it now is approaching the original mean projection. Alabama has been below. Louisiana is a little bit above. Mississippi, Arkansas. And so I think you can begin to see a pattern here in terms of why different states are taking different decisions with regards to opening up the economy and moving from them. In terms of Illinois, moving into the Midwest is above, Michigan's above, but Minnesota's below. And so, again, different experience from the projections. Texas has been below. Colorado is below on the cumulative. Arizona has been below. New Mexico below, but within the 95% confidence interval. California is below, but again within the 95% confidence interval, same as Washington. We then move to Alaska, who's well below, and Hawaii also are well below. And so again, you can see how regionally there has been different experiences. So maybe just to conclude here, this model has been used to drive policy decisions, resulted in large negative effects for the U.S. in general and the egg economy specifically. The change in data definition of death has had an effect on the projections, and this makes modeling extremely difficult. There have been fairly large revisions to the death totals, and in some respects, the difference in the way death is counted, whether or not it's attributed to the coronavirus or not. And so both of those make modeling very difficult. The model has added additional variables, and certainly that's going to increase the in-sample fit. The big question is whether or not it's going to increase the out-of-sample fit. More variables does not necessarily improve the out-of-sample fit, a well-known issue in economic modeling. And then finally, we'll end with the question, and we've had this question to look at again. Are the revisions and are the results we're getting due to society flattening the curve, or are they due to inaccurate models? And certainly that's something that is becoming fairly political, and certainly different individuals will come to a different framework with regards to this. And so with that, we appreciate your time, and hopefully this has given you something to think about as we look at probably one of the major economic effects and medical issues that we've had in my lifetime for that example. And so with that, we will be back next week where we'll kind of follow this in the next week. Have a good week.